Total surface area of a hollow cylinder is given by the formula A equals to 2 pi times capital R plus small r times capital R minus small r plus h. We will actually see in this video how do we isolate the outer radius of this hollow cylinder using strategies of completing the squares. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll understand how do we change subject to R for the total surface area of a hollow cylinder. Formula given to us is A equals to 2 pi times R plus R times R minus R plus H. You can look into my video on derivation of this formula also. Now, let us try to figure out a strategy to isolate the capital R. Well, let's rewrite the formula, which is A equals to 2 pi capital R plus R times capital R minus small r plus h. Hollow cylinder is shown to you. Now it is made up of two thin plates, outer having radius of capital R, inner having radius of small r, height being h, right? So you can derive this particular formula. As I said, you can also watch my video for the derivation. But here we are focusing on one very important topic, and that is how do we isolate or change the variable to capital R. Now, for doing so, we may have to expand and simplify. You can see expanding and simplifying may be complicated, but here is a strategy. The strategy is that what we can do is we can multiply R plus R with R minus R first, right? So let's make a bracket here. We'll multiply R plus R with R minus R and then add R plus R with H. You get the idea. Now that is a very critical step to get the result. Perfect. So this gives you A equals to 2 pi, and now the product of R plus R times R minus R will be R square minus R square, right? And here, what do we get? We get RH, capital RH, plus small rh. Perfect. Now this helps us to get the terms in R, rather the quadratic equation in capital R, right? So let's isolate capital R. To do so, I'll prefer to divide by 2 pi first. So we get A over 2 pi. And here we can see we have R square plus RH. And the other terms are minus R square plus RH, right? So now let's write down the equation in quadratic form where the equation is in R square, bringing all of the constants on one side, right? So we can rewrite this as R square plus RH equals to these terms to the left side. So we have A over 2 pi plus R square minus RH, right? So we have this equation. Now, how do we isolate R from this equation? It's a quadratic equation, correct? So now, let us continue with this expression on the next page. We have R square plus RH, R square plus RH equals to a by 2 pi plus r square minus rh. To isolate capital R, we could actually complete the square. So the method adopted will now be to complete squares. So to complete the squares, we will write the coefficient of capital R, which is h, half of it, and square both sides, right? So we could write this as r square plus r times h plus h by 2 whole square. So we're going to add this term on both sides. We get a over 2 pi plus r square minus rh plus h by 2 whole square. You see that. Now the left hand side can be written as capital R plus h by 2 whole square. And the right hand side, I can replace all this with a constant, let us say k, where k is equals to a by 2 pi plus r square minus rh plus h by 2 whole square, right? So now we can square root. So we have r plus h by 2 equals to square root of k. Now since all these dimensions are positive, we'll take positive root. And that helps us to isolate r, which can now be written as square root of k minus h by 2. Right? So that is how we could isolate r. And clearly, what is square root of k? Square root of k is equal to square root of a over 2 pi plus r square minus rh plus h by 2 whole square, right? So that is what square root of k is. But anyway, we have easily, with some strategies, isolated r. So r is equal to a constant square root of k minus h by 2, where k is all this, right? You could also write k as equal to a by 2 pi plus r square minus rh plus h by 2 whole square. Is that clear to you? So that is the way to isolate r from the total surface area A of hollow cylinder. Perfect? I hope you find it interesting and useful. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. And in case you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.